Today's the big day, folks. Today we begin looking at Module 2. We're going to do a lot more multiplication, a lot more division in Module 2. We're going to build on a lot of the things from Module 1. Place value will continue to be a big deal, so if you're still having difficulty with some of your places, some of those columns, please make sure you go back and check those. Look at your old notes, rewatch some old videos, check online. Because in Module 2, we'll still need to know that stuff. All right, Module 2, we're back to Lesson 1. So back to Roman numeral 1. It's just 2-1 this time. So Module 2, Lesson 1. Today we're going to talk about using mental math to multiply. Using mental math to multiply. Okay. Now there's really no vocabulary on this one that we need, so I'm not going to start with any vocabulary, but I am going to start with a big idea and show you a few examples of how we put it into practice. Let that thing focus a little bit. There we go. The big idea that I want you to hang on to is this. You can use place value. That's why I was prattling on about that earlier. You can use place value, patterns, and fact families. I'm kind of going off the edge there. Fact families. You can use place value, patterns, and fact families to multiply mentally. For example, we have a basic fact family, 5 times 7. I guess we're not building up an entire family yet, but this is a basic multiplication fact that I think most of you are familiar with. Most of you are already yelling at your computer, it's 35! It is 35. What we're going to do is extend that. We're going to say, okay, 5 times 7 is 35. Well, what if I have 50 times 7? Well, 5 times 7 was 35. This right here is 10 times bigger than my original 5, so my answer ends up being 10 times bigger. This works for any multiple of 10. So basically, it doesn't matter how many zeros I add on to that. I still use that basic fact, 35, and then just put that many zeros. 1, 2, 1, 2, right over there. Now it works with both factors. For this one, I kept changing the first factor. I kept making it 10 times bigger. But again, it doesn't matter. We know that 5 times 7 is 35. Well, 5 times 70 is 35, but 10 times bigger. 5 times 700 is 35, but 100 times bigger. And hopefully looking at this, you're also recognizing the order of the factors doesn't really matter. Okay, 5 times 7, 5 times 7, 5 times 70, 50 times 7. We'll talk in a couple lessons about how switching the order 7 times 5 would still give you the same answer. But hopefully that makes sense. Okay, if one of the factors gets 10 times bigger, then your answer is going to get 10 times bigger. If you think about it going up from the bottom, 700 to 70, if one of the factors gets 10 times smaller, then the answer gets 10 times smaller. Okay. Now, I'm going to show you the process. And again, we're talking about multiples of 10. We love multiples of 10. Not quite as much as we love powers of 10, but multiples of 10 are pretty cool. Multiples of 10 are just anything that you multiply, or excuse me, a multiple of 10 is the product you get when you multiply something times 10. Got a little ahead of myself there. Okay. 50 is a multiple of 10. It's 5 times 10. 500 is a multiple of 10 because it's 50 times 10. Okay, step 1. You are going to box any non-zero digits. Now obviously this is just when we're working with powers of 10. Later when we get to numbers that don't really have a lot of zeros, this isn't going to help you anymore. But anytime you have a number that ends with 0, again a multiple of 10. Boy, I'm all over the place today. Anytime you have something that ends with a 0, a multiple of 10, you're going to use this process. Okay. 300 times 20 times 120. Okay. You may be looking at these and feeling like, oh, these are some big numbers I'm multiplying, but because of all those zeros, I can take some mental shortcuts. I'm going to box up any non-zero digits, anything that's not 0. When I get over here to 120, I want to keep the 12 together. We've talked previously about how 120 could be the same as saying 12 groups of 10, 12 tens. That's what we're doing here essentially. Okay. If you're looking at this and saying, well, why didn't I do 30? You could, but you end up with a bigger number. It's harder to do mentally. So anything that isn't 0 gets boxed up. If you have a couple that aren't 0 and they're next to each other, box them together. Okay. Moving on with our multiples of 10. Multiples of 10. We are going to multiply just the box digits. Multiply just the boxed digits. Okay. We're not going to worry about the zeros right now. We will deal with them later. Okay. Now, I am going to put a note in here. We haven't really discussed it in any of the other videos, so this is going to probably not make a lot of sense yet. But I want it here because we are going to talk about it later in the module. Use the associative property. What? The associative property if you can. What is that? We'll talk about it more in class, but the short version is this. The associative property is something fun in math that says if I'm multiplying 3 things, 4 things, 5 things together, it doesn't matter how I group them. It doesn't matter which 2 I start with. Let me show you. Here's our 300, right? I'm going to kind of ghost out the zeros. Ooh. We'll pretend they're not there. We don't want to get rid of them entirely. We don't want to erase them, anything crazy like that, because we will need them. But for now, we can just kind of ghost them out and pretend that they're not there. Okay. There we go. Now, associative property means you can multiply these numbers together however you want. You can multiply 3 times 2, get an answer, 6, and then multiply 6 times 12. Okay. Now for me, 6 times 12, that's not too bad. For some of you, 6 times 12, that's not too bad. But wouldn't 2 times 12 be even easier? Wouldn't 3 times 12 be even easier? Watch this. I am going to group 3, okay? I am going to multiply the 3 times 12 first. And that's what the parentheses mean. The parentheses mean we're going to do this part first. Now the reason I'm doing those 2 together first is because usually doubling things is pretty easy. You may find that it's not. Again, the 3 times 2 is 6. 6 times 12, that might be easier for you. You might be screaming at the computer, I know what the answer is. That's okay. You're going to pick the way that works best for you. That's all the associative property is saying. 3 times 12 is 36. Now I'm multiplying that times 2. Okay, well, the answer to that should be 72. And 6 times 12 would also be 32. If I multiply 2 times 12 to get 24, 24 times 3 would be 72. It's all going to be the same. All right, let's wrap this thing up. I'm going to leave that on for just a moment, but I know my 72 is kind of sliding off the side. There we are. So step 3, and don't worry, this is it. Step 3. We're going to count the zeros. We're going to count all those zeros and put them, count the zeros and put them after the product. Okay. We're going to count the zeros and put them after the product. So, make you write this one more time. 3, leave a lot of space, times 2, leave some space, times 12 is equal to 72. And right, we just got that up here. Okay, we did that part already. Now, slide this up a bit. This was originally 300, so there's 1, 2 zeros. This was originally 20, so there's 1 there. This was 120, 1 there. 1, 2, 3, 4 zeros total. Means 1, 2, 3, and 4. 4 zeros in all the numbers means 4 zeros in their final answer. So, 300 times 20 times 120 is equal to 7, 2, 1, 2, 3, 4. And when I put the comma to separate the periods, ones, tens, hundreds, bloop, here's my thousands. I get my final answer. 300 times 20 times 120 is equal to 720,000. Now the hope is that once you get used to this and practice it, it'll go much faster. You'll see this and just mentally say, that's a lot of zeros. So 3 times 2 is 6. 6 times 12 is 72. 1, 2, 3, 4 zeros after that. Write a 72 with 4 zeros. Done. This is not estimating, but we're going to use it later with estimating. Again, you're not going to be able to do this unless the numbers end with zeros, unless you're dealing with multiples of 10. But when you are dealing with multiples of 10, it's pretty nice. All right, thanks folks. We'll do some more practice and see some more examples tomorrow during class. I will see you soon.